our final 45, 45, 90-degree triangle problem. Let's do it. So example 4, I have a right triangle, side of a right angle. I know this side is an x and this side is a 6. Now, first of all, if I'm going to solve using either the Pythagorean theorem or my ratio, I need to at least know 2 of the sides or be able to solve for one side, okay, which currently I'm missing another side. And in order to use the ratio, I must have a 45, 45, 90-degree triangle, which in my picture, it's kind of hard to tell what kind of triangle it is. Well, the key thing that's giving it away, since my 2 angles right here are congruent, my base angles are congruent. Which type of triangle has congruent base angles? That would be an isosceles triangle. So, since my base angles are congruent, I know the 2 sides across from them are also congruent. And since I have an isosceles right triangle, holy hot dog, that means I have a 45, 45, 90 triangle. Whoa. Alright, so this is telling me I can solve by either using the Pythagorean theorem or the ratio. And again, you can technically always use sine, cosine, and tangent to solve for the missing sides of a right triangle. Well, let's get to it, you guys. So first of all, since this is an isosceles triangle, 2 sides are congruent. So if this is x, this side is also x. Okay. Well, the Pythagorean theorem, my A and my B are the 2 sides of the right angle, which is right here. So I'm just going to call this one A and this one B. The C is the hypotenuse, which is the side directly across from the 90-degree angle. Alright, let's set this bad boy up. So we have x squared plus x squared equals 6 squared. Alright, when you add 2 variables together, remember you do not touch the exponents. You simply add what is in front of each variable, or the coefficients. Which in this case, since I don't have any coefficients, my coefficients are secretly 1. And 1 plus 1 will give me a 2x squared. And that will equal 6 squared, which 6 times 6 is 36. Alright, I need to get x by itself. Currently, that 2 is getting in the way. Which, since the 2 and the x are secretly multiplying, the way that I move 2 to the other side is by dividing that bad boy on both sides. 2 divided by 2 will cancel and turn to 1. So I'm left with 1x squared, or x squared, equals 36 over 2, which is 18. Alright, and I'm so close to solving for x, but currently that squared is getting in the way. How do you undo a squared, or what is the inverse of a squared? Holy hot dog, that would be a square root, and I'm going to square root that thing on both sides. Okay, which the square root and the squared will cancel each other out. So I'm left with x equals, when you square root both sides of an equation, a plus or minus will appear. Okay, and then the square root of 18, which is 18 a perfect square. It is not, which means in order to simplify down my square root, I need to do a factor tree and break it on down. So let's break it on down, you guys. Okay, 18 will break down into, let's see here, 9 and 2 will work, and 9 will break down into 3 and 3. Okay, which don't forget, all the cute couples get to leave the house to go on their math date, while the lonely single numbers have to stay inside. So my cute 3 couple will hop outside the square root, and then my lonely single 2 will stay on the inside. And then don't forget, you guys, since we're solving for the sides of a right triangle, only the positive answer will make sense. So my final answer is positive 3 root 2. Alright, and we can do the same thing by solving using our ratios. Okay, so the leg in my ratio, that is either side of the right angle in the right triangle. So this could be my leg or this one. Doesn't matter which one you pick. And then the h, the hypotenuse, is the side directly across from the right angle. So this side. Alright, let's set it up. So 1 over the leg, which the leg is x, will equal root 2 over the hypotenuse, which the hypotenuse is 6. And guess what, you guys? We now need to cross multiply. So x times 2 is going to be root 2x. And that will equal 1 times 6, which is 6. Alright, and then now I need to move that root 2 to the other side, which, since they're secretly multiplying, the way that you move a root 2 to the other side is by dividing it by root 2 on both sides. Okay, which root 2 divided by root 2 will cancel and turn to 1. So I'm left with x equals 6 over root 2. But you're probably like, Miss Long, we didn't get the same answer. Oh no. Well, if you remember from example 1, we ended up with a radical in the denominator. And remember, if you want to write your answer in its most simplified form, we cannot have a square root in the denominator. Okay, technically, you guys, these two are the same answer. If I type it into my nifty, handy-dandy calculator, let me pull that up. Okay, if I type 3 root 2, so 3 square root. Man, I keep doing that. Sorry, guys. Stop it, Miss Long. I'm just going to clear it out. Clear. Okay, 3 square root. Jeez Louise. 3 square root 2 is 4.2. And then if I do 6 over the square root of 2. No. Sorry, guys. Me and this calculator don't get along. 6 divided by the square root of 2. There we go. If you see, they are the same exact answer. But as a mathematician, we want our answers to look the same on our paper. Okay, so we need to simplify down this fraction, and we do not want a square root in the denominator, which, if you ever end up with a square root in the denominator, how we simplify the fraction down is by doing something called rationalizing the denominator. So we want to get rid of a square root. The opposite, or the inverse of a square root, is a square. So if you square a square root, the square root will go away. So if you square a number, that means to multiply it to itself. So if I multiply root 2 to itself, it should make the square root disappear. But don't forget, I'm not trying to change the value of this number. So if you multiply it to the bottom, you got to multiply it to the top. Just like when you get a common denominator in a fraction, whatever you multiply to the bottom, you got to do to the top. All right, so let's do this, you guys. So I have x equals 6 root 2 over, well, since both of these are under a square root, I can multiply them. So it'll be the square root of 2 times 2, which equals 6 root 2 over the square root of 2 times 2 is 4. And that will equal 6 root 2 over, what's the square root of 4, you guys? Well, the square root of 4 is 2. Whoa, look at that, you guys. See how when you multiply a square root to itself, it makes the square root go away. Okay, it's kind of like we're doing root 2 squared. So the square root and the square cancel, and you're simply just left with the number underneath the radical, which in this case is a 2. So that's kind of a shortcut. Whenever you multiply a radical to itself, the square roots will cancel out, and you're left with the number under the radical, which in this case was a 2. So there you go. Okay, you guys, in the last step, I need to simplify down my fraction, which, remember, you can only divide values that either have square roots together or don't have square roots together. Okay, so I only have one square root, so I'm just going to leave the square root alone. Okay, but I can divide the two numbers in my fraction that don't have square roots. And 6 divided by 2 will give me a 3. And then I'm just left with this root 2. And look at that, you guys. We ended up with the same answer, which is awesome. Guys, and again, if you don't like this, so after doing 4 examples, if you're deciding, well, I don't really care for doing the Pythagorean theorem and the ratio, if you would rather solve using sine, cosine, and tangent, that is also an option. So I'm just giving you guys as many options as possible to solve for the sides of right triangles. Well, there you have it, you guys. Excellent work. Toodaloo.